Assalamualaikum and hi everyone. So today I will brief you guys about the introduction of the topic. First, Newton's law explains how object move. A force like a push or a pull change the motion of an object. That is Newton's first and second law in action. An object will stay or move unless a force acts on it. And more force means more acceleration. Now, here is something more interesting. We can also use a similar idea to explain how heat moves. When there's a big difference between an object's temperature and the air around it, heat flows faster. This is actually described by Newton's law of cooling, or we can also say that it is warming law. So this law can be used to explain about the defrosting of frozen meat.
Okay, next, let's go into the situation and problem that we have. Okay, so from the situation that we have, we need to conclude that the frozen meat was taken out from the freezer in negative 7 degrees Celsius to defrost. It left out for about 50 minutes in the room temperature 25 degrees and its temperature increased to 1 degree Celsius. So we need to calculate when the defrosting meat temperature will change to 5 degrees Celsius. So we have the question. The question is, what is the temperature of the meat after 35 minutes?
Okay, from the given problem statement, let T represent the temperature of the meat at any time T in minutes. Based on the data, we have the following conditions. First, T0 equals to -7. Second, T15 equals to 1. Then we have T equals to 5. We want to find the value of T when the meat reaches the temperature. Last, T35 equals to what? We also want to find the temperature of the meat at any time T, 35 minutes. Now, let's calculate the first part of the problem, which is when will the defrosting meat temperature reach 5 degrees Celsius. Now, we will calculate when the defrosting meat temperature will change to 5 degrees Celsius. First, we write the equation as dt over dt equals to k T minus Ts. Ts means surrounding temperature. dt over dt equals to k T minus 25 because the surrounding temperature is 25. Then, we use the separable method, which is we need to integrate both sides. For the left side, we integrate dt over T minus 25 equals to right side integrate k dt. And then we get ln T minus 25 equals to kt plus c. Then we want to get rid the ln. Then we get T minus 25 equals to cekt. T equals to 25 plus cekt. Okay, next step, we must determine C. So from the first condition, T0 equals to -7, we substitute into the general formula. We substitute capital T with -7 and T minutes equals to 0. And then we got the equation -7 equals to 25 plus cek0. Therefore, we found that the constant C equals -32. Now, to complete the equation, we need to find the value of K by using the second condition, which is T15 equals to 1. And then we substitute capital T with 1 and T with 15. And we got this, the K equals -0.0192. Now that we have found both C and K, then we can write the new equation as T equals to 25 minus 32 E negative 0.0192 T. And by using the third condition, which is T equals to 5, we can substitute the value of capital T into the equation. And we got 5 equals to 25 minus 32 E negative 0.0192 T. And we calculate until the final answer, we get T equals to 24.48 minutes. And this is the answer for problem 1.
Let's go through the last question where we want to find the temperature after 35 minutes. We take the last condition, T 35 equals to what? Because we want to find the T temperature. We substitute T equals 35 and the formula can be written as T equals 25 minus 32 E negative 0.0192 bracket 35. And we calculate the formula. After that, we got the answer T equals 8.66 degrees. Therefore, the answer for the question, the temperature after 35 minutes, is approximately 8.66 degrees.
So now we are going to talk about the conclusion. Newton's law of warming or cooling can be modeled using a separable differential equation method by allowing us to determine how temperature responds to time. This model also has widespread application in areas such as in physics, engineering, chemistry, and environmental science. For example, how temperature frozen food change while defrosting, or how a hot drink cools in room temperature.